Hi there, everybody. Welcome to the Pentesters Chat, the first edition here. Today, we're going to be talking about a project that we built called Gigaproxy. Before we hop in, though, just some quick introductions. My name is Nicholas Anastasi, the Director of Technical Operations here at Sprocket Security. And then I also have
I'm Joseph Morris. I am the DevOps engineer at Sprocket Security.
Awesome. So first and foremost, definitely open to questions. So if anything comes to mind, please drop it in the chat and we'll address it throughout the conversation here. Uh, I guess to start, right, let's talk about the project Gigaproxy. Fun name. One of the things we run into as penetration testers, especially at Sprocket Security, is scanning infrastructure at scale and more specifically bypassing web application firewalls. There's a lot of great tools out there to assist with this, but not one ended up really fitting the bill for us to accomplish the goals that we're trying to accomplish, right? What we found with existing tools like Fireprox or Proxy Cannon, they don't handle multiple targets very well. And we can talk a little bit about that from a infrastructure perspective in a little bit here. There are other tools out there as well are quite expensive and time intensive to keep working and actually maintain. And then finally, it's quite difficult to actually perform tracking of the requests as they go outbound through some sort of proxying or VPN solution like you might see with Proxy Cannon NG. Joe was the kind of brainchild behind this idea. Joe, do you want to talk a little bit about our alternate approach that we came up with?
Yeah, for sure. So we sort of built off of Fireprox's idea of using API gateway, but one of the limitations of the Fireprox implementation, well, there are two big limitations, was with Amazon API gateway, you can only specify a single endpoint to hit, and then also it attaches some headers to the outgoing requests that identify your traffic is coming from Amazon API gateway. So what we figured out was that you can actually, instead of going directly from API gateway to your endpoint, go through a catch-all Lambda function that acts as a basically like an intermediary proxy. It just sends a request out from whatever your inbound request is, and then you can modify the headers as needed, put in your own headers for like user agent, things like that. What we also found was that when and for those of you familiar with AWS, you probably already know this, but to give a short background, with Lambda functions, they are there's a cold start when they're first invoked, and they will basically like load into an execution environment, get one static IP address for a certain amount of time, unless like a bunch of Lambda functions are run at the same time. What we found is that you can actually arbitrarily force a Lambda function to get a new IP address regardless of how much traffic you're passing through it by just updating some non-important value on the Lambda function, like the description. So what we're actually doing is we have what's called a Amazon Event Bridge function, not function, sorry, a schedule, basically like a cron in AWS that is going to run every minute to update just the description of the Lambda function. It's just going to update with a timestamp. And basically, what that causes is the Lambda function to keep reloading. So even if you're not passing a whole bunch of traffic through Gigaproxy, and even if you are, you're going to get a new IP address at the very in the very worst scenario once every minute. So much better IP address rotation, something like Proxy Cannon, and then also the ability to modify those outgoing headers like in as you couldn't do in like Firefox.
Yeah.
Yeah.
No, awesome explanation, Joe. One of the things I guess we ran into next, even after we had this architecture designed and Joe had built it out, right, was the ability to then pass the testing tools we use on a daily basis onto this API gateway that would subsequently go and pass traffic through that Lambda function Joe was talking about. So, right, just for some context, what we found is you need to add extra information to your HTTP request when you're trying to proxy through API gateway and subsequently Lambda. Specifically, you need to tell the Lambda function, where am I supposed to go, right? So, with the traditional Fireprox API gateway methodology, you pre-staged the API gateway endpoint to redirect traffic to a specific location. So you could tell it, hey, all the inbound requests to this API gateway, forward them on to outlook.office365.com. But our solution here, what we wanted to accomplish was, right, like we said before, arbitrary forwarding to a large number of hosts. So what we ended up, or Joe built out initially, was some Python code that we have listed in the blog that would take an inbound request and then look at a header called X forward me to. This again is all shown in the GitHub repo and the blog article itself. Take that X forward me to kind of header and the value in there as an authority, and then route the requests arbitrarily onto that host. All right, awesome. The one thing that you're going to find there, though, is nuclei, buff, bbot, a lot of the tools that we've written here at Sprocket, they're not, without significant modification to the code, you're not able to actually append that header with information about where the request is supposed to go. So if you were to just take a tool base, right, and try to send it through the Gigaproxy, it wouldn't know where to route itself because that X forward me to header would be missing. And what we ended up doing, right, was diving in and saying, hey, we can actually play with man in the middle proxy here. For anybody not familiar, you are probably familiar with Burp Suite. Burp Suite is just kind of an HTTP proxy. Man in the middle proxy is similar in a sense that you can modify requests on the fly. So I can take man in the middle proxy, I can tell it to listen on a port on my local host or really on any IP address. And then any tool that I have that supports a proxy will be passed through man in the middle proxy, right? What the man in the middle proxy code looks like, basically, whenever a request, let's say, for example, comes outbound through nuclei, it is a proxy is specified, an HTTP proxy is specified that points to a man-in-the-middle proxy or man-in-the-middle dump, web, whatever variation of it that you're using. It takes that request, right? It looks at the target URL that nuclei is trying to send the request to. It adds a header with that value and then forwards the traffic onto the actual API gateway that's going to trigger the Lambda function and forward it out. So what that basically means, on any post that you have, you can start up a man-in-the-middle proxy script that we wrote and then take any arbitrary tool that supports proxying, but then specify in that tool to pass traffic through your local man-in-the-middle proxy instance. The whole entire HTTP request chain, will go end to end. You'll get your responses back. There are some caveats we can talk about, but for the most part, now all of a sudden you have a proxy that will rotate your IP at least every minute based on the infrastructure that Joe built. There are some really cool things we found on that front, but I want to pass it back to Joe to maybe talk a little bit more about infrastructure, if you have any kind of additional notes there and your knowledge of AWS.
Yeah, for sure. So kind of dipping into why someone should care that we built it in this way. All the services we're using are highly scalable. So API Gateway and Lambda both, they're going to be a pay-as-you-go service provided by AWS. So fitting in with their serverless model, which basically all means that this isn't just running on an EC2 instance. It's all going to, or a persistent server, whatever. It's all going to scale up and down with however much you utilize it in a month. So you might see in the blog, we include a little cost calculator to estimate maximum cost with the default quota we set on the API key in the Terraform code. that is like a theoretical maximum. So that is, if you don't use it a month or if you use half of it a month, you're not going to get charged that full amount. So, and also it's also going to be able to meet your demand as well for how many actual requests you're passing through for a scan across the team or across, you're really only limited by that API key and also some limits on the AWS puts in place on API gateway, but most of those are modifiable through a service quota increase. But most people won't hit those limits with regular usage, so we'll consider it out of scope for this talk.
Definitely. Yeah. And what we kind of set out to do after Joe did the initial proof of concept, we got the man in the middle proxy script working, was to actually terraform this out so anybody could use it. I am not the smartest person when it comes to HCL and Terraform code in general. Joe's the genius on that front. So he went ahead and wrote that really quick. We actually did it in an afternoon. Which is really fun. And then we were able to kind of automate the deploy process. Cool question I've been asked is really like success stories and things around this. That afternoon, while we were building the repeatable infrastructure, a team member that we had did some buzzing at scale, and I believe landed on 6 or 7 instances of high severity cross-site scripting across our customer base. So that was pretty fun. Pretty cool. I've also leveraged it with some other tooling, really just so I don't have to worry about my traffic getting blocked. Because what you'll see with a lot of the tooling out there, you're kind of blind to what's happening if WAF is blocking you or something like that based on your source IP. You're in the ether, right? You just don't know. One of the things that I've found, one, it's a set it and forget it solution, but then additionally, right, man in the middle proxy is not necessarily built to do what we're doing with it, but it's actually really, really good at accomplishing our goal, especially as like ethical testers or ethical pen testers, because not only can we, do all this evasion, but we also get a lot of context on our requests as they're being sent. So similar to Burp Suite, kind of like I talked about, we can see in man in the middle proxy, right, what the outbound request looked like and the response looked like from AWS. You can even hop into CloudWatch and actually look at the logs as they're happening with those outbound requests. That I can see even being valuable for entire testing teams, right? So they can see like the volume of testing or what those requests looked like when they were going out the door, that sort of thing.
Uh,
When it comes, oh, go ahead, Joe.
Sorry, real quick, just to jump in regarding logging. So there's a number of Terraform variables you can set in the project as well. One of them being enabling that logging that Nicholas just mentioned. It is set to false by default just to control cost. In the README, we go over how you can set it to true in your Terraform apply function. Very easy, but just be aware of that. If you want that logging enabled in CloudWatch, you just have to go into add one Terraform variable. So sorry, I'll pass it back to you, Nicholas.
No, yeah, you're all good. Yeah, there's a lot of not undocumented, but great ways that aren't readily apparent to kind of assist with tracking on this one, and kind of see what's happening along the way, getting more visibility into your tooling, which is really valuable. There is a hidden parameter built into we have it slightly documented in the GitHub repository, but there is a hidden header that you can add to any outbound requests through the man in the middle proxy script to actually do a little bit of debugging so you can see the whole request and response chain out there in Lambda by looking at a log stream. They don't get to see traditionally, which is really, really cool. One other thing I'll mention here, right, that I think we kind of glossed over with tools like specifically Firefox, you create the endpoint and you put it out there on the internet. By default, there's no authentication associated with that. So if somebody was able to enumerate your API gateway endpoint, you could just arbitrarily use it. Well, not super likely. It's still, not protected infrastructure. During the Terraform apply and push of the infrastructure out, a automatically generated API key will be created. And when you run man-in-the-middle proxy locally on your box or on an external server, you have to also pass that API key. So your tooling is actually making those requests to your AWS infrastructure from an authenticated perspective, as opposed to just kind of anyone out there on the internet being able to utilize your infrastructure. Um, One of the questions we've got in the chat here that I think we should answer. How can scalable proxies help overcome challenges in bypassing web application firewalls? Again, it's something we might have glossed over a little bit, but definitely worth calling out. So, modern web application firewalls have a lot of pieces to them to actually detect malicious traffic, very similar to an EDR solution in some ways, right? So, they have base signatures where they'll detect certain attacks. They also have other sort of customized signatures built for specific use cases of the application that's being targeted, things like that. But more often than not, the easiest way to detect an attack is to look at the frequency of requests coming from a single IP address. That's why IP rotation is so valuable. Another reason it's very valuable, and I'm sure if any testers are watching this, you've experienced it at some point or another. If you don't rotate your IP addresses, you end up on block lists that propagate out to other web application firewalls out there. With that being the case, right, if you get blocked in one place or you're scanning one customer's infrastructure and your IP is banned for whatever reason by a WAF, there's a chance that that IP will bleed over into being blocked by some other WAF or security solution out there. So IP rotation is very, very important in that sense. And IPs, while they're, AWS owns a lot of them, are hard to get a hold of in certain cases. Proxy canon, for example, right, is limited to the number of nodes that you spin up. And with that being the case, right, you pay for every single EC2 instance in that node architecture and kind of client server architecture that Proxy Canon is using. With the solution here, more specifically, we're focused on the the fact that Lambda functions execute in arbitrary environments throughout AWS. Arbitrary, it's not completely arbitrary, correct? Like there is certain IP ranges that they're restricted to.
Yeah, so right now, Gigaproxy is launched into one AWS region, which is, for those not familiar with AWS, it's a collection of data centers in a geographic region. So if I'm in like, US East 1, that's going to be in Virginia, Northern Virginia, I believe. So you're going to have that IP range to rotate through versus if you launch in US West 2, which is in Oregon, that's going to be a whole separate IP range.
Definitely. Joe, do you know when, so does Lambda have a specific IP range that it'll exit out through, or is it kind of placed arbitrarily in EC2 IP ranges? How does that look?
AWS publishes their IP ranges, but I don't believe they segment them based on like Lambda versus EC2 because under the hood, I believe Lambda will use like similar like network interface what's the term? Network interface approach that EC2 uses. So essentially, I believe it's all going to come out the same way. There's not really a way to like differentiate it. I could be wrong. They may have updated that, but from when I last checked, it's all part of like a couple big blocks. Yeah.
Cool, cool, cool. Yeah. So, I just talk about, I guess, what you can do today to leverage the Gigaproxy and also touch on some limitations that the tool has. And we would greatly appreciate someone diving in and helping us out with it. To actually deploy Gigaproxy, we have a blog on our site, literally called Gigaproxy. that it links directly to a GitHub repository. That GitHub repository has the full kind of instructions on how to get everything set up. Um, and it's really just you need Terraform on your box and access to an AWS account. I would say do not leverage your production AWS account because you are sending scanning traffic out, but should be fine for most testers out there. Pretty easy to leverage. Once you've deployed the or ran the Terraform code, got your infrastructure built, you will get a API gateway endpoint that you'll need to run man in the middle proxy, and you also get an API key unless you pre-specify one. Then on your local host, you got to make sure that you have man in the middle proxy installed and also install the certificates from man in the middle proxy, very similar to Burp Suite. That's something that gets missed a little bit during setup, so I want to call it out in particularly. Just make sure those certs get installed properly. And then from there, you can start up man in the middle proxy with the specific configuration options on the command line. Usually we'll do it in like a screen session, so it's kind of there permanently. And then, like I said earlier, tool your choice. Bbot supports custom HTTP proxies. Been using it through there with a ton of success. Same with Nuclei, Buff, any really semi-mature tool that gets released nowadays has HTTP proxy support. One thing to note, right? Port scanning or TCP like network connections with port scanning or yeah, non-HTTP connections will not route properly through this tool. It's limited to HTTP connections. Another thing to note, even if you're not running this remotely, you could also pass it through or pass burp through it as an upstream proxy. So even like full GUI applications can leverage this without issue. Very, very valuable. Joe, do you want to talk about the one limitation that we see on our end that we're looking to fix here?
Yeah, so the handling of binary data. So because um, so API gateway will handle binary payloads in a certain way. Basically, it base64 encodes them before it sends them to Lambda. And then from how we've been working with it, we're still trying to work through potentially a way to be able to have API gateway pass a binary payload response back through back through itself that will not base64 encode, but that can potentially lead to tools like Nuclei or whatever. If it's expecting a certain response and getting it in base64, it can potentially throw some things off. We are sending I believe it's a part of the payload, a is base64 encoded parameter that is set to true or false, depending on if the payload is base64 encoded or not. And you reasonably assume that if it is base64 encoded, it's binary data. So if your tool is able to handle, base64 decoding, you can do it from there. But that's one limitation right now. Yeah.
Yep. It's not that big of a deal, I'll say, at least based on my experience with the tool. Things like favicon checks, trying to fingerprint websites with specifically binary data, will fail, which can hurt, testing methodology in certain cases. But overall, the big win exploits and things and buzzing we've been trying to do has been working just fine. That this is like a nice to have, in my opinion, and at least from my perspective, when I've thought about it, I think there's a lot of mods that can be made to the man in the middle proxy instance locally. So as that traffic is passed back, there's potential to actually do that decoding, but we haven't played around with it a ton yet, to be honest. Yeah. Let me see if there are any more questions here. Uh,
If there
what's
are,
that's oh,
we can also talk about next steps as well at the end after
oh shoot,
questions.
yeah, let's do that and then we'll get to questions here. Yeah, let's talk about what's coming up. What we're working on this front, Joe.
Yeah, for sure. So we've been looking at expanding to other cloud providers, so being able to utilize a wider range of IP addresses. Um, of course, we have to be cognizant of quality of IP ranges too. There's certain cloud providers that are more commonly used for scanning, so those IP ranges are going to be probably more aggressively controlled by a lot of WAFs. So we're being pretty selective in which ones we look at. Nicholas already mentioned, ongoing work with man-mill proxy, binary data handling. Um, we're also about to merge a pull request that implements some optional Terraform code to create an EC2 instance that'll install man-mill proxy on a Ubuntu 22.04 host. Pretty small host, it's a T4G micro EC2 instance type, which is like fractions of a penny to run per hour. It's very much want to emphasize this. It's a temporary um, solution. I wouldn't want to use this in production or for a long period of time because of patching and things like that. There's no automated patching on it, but it'll get you at least in a state where you can troubleshoot where if you're getting into issues with man-mill proxy or Gigaproxy or the API gateway, like where it's happening. So definitely excited to call that out as well.
Yeah, definitely. Had a lot of people reach out and talk to us about using this for like a team setup. And so that's kind of one of the reasons Joe built this out as well. Having a centralized location that you can host man in the middle proxy that team members can point at to just pass their tools from, instead of having to start that proxy locally every time you want to actually evade controls. So that makes it as easy as memorizing, or even, I mean, if you want to set a DNS record, memorizing the IP or DNS record for this shared proxy location, and then any tool on any box anywhere, you can specify this remote host and the port that it's going to be listening on, and just pass your traffic off. So yeah, regardless, really appreciate everybody's time. If there are any questions, Joe and I are both on LinkedIn, or we can be reached out to via email. The blog and project is evolving, and we're going to continue to work on it here. But overall, so far, we've had a lot of success, a lot of really good feedback, and we encourage you to go try out the tool on GitHub and read our blog for some really kind of technical, in-depth content surrounding what we accomplished. So coming up soon, we do have another Pentester chat that's going to be in the near future here. So keep an eye out for that, and we'll hopefully be doing these for quite a while going forward. So show off some of the sweet things we're doing here at Sprocket on the pen test, or really just kind of by any of the technical teams internally. So thank you, everybody.